Floating nuclear power stations, Russian, lit floating combined heat and power, CHP, low power nuclear station, are vessels designed by Rosatom. They are self-contained, low-capacity, floating nuclear power plants. The stations are to be mass-produced at shipbuilding facilities and then towed to the destination ports of the cities and towns experiencing deficit of power due to industrialization. The work on such projects dates back to MH-1A in the United States, which was built in the 1960s into the hull of a World War II Liberty ship. However, the Rosatom project is the first floating nuclear power plant intended for mass production. The initial plan was to manufacture at least 7 of the vessels by 2015. In 2000, the project for a floating power station began when the Ministry for Atomic Energy of the Russian Federation, Rosatom, chose Severodvinsk in Arkhangelsk Oblast as the construction site. Sebmash was appointed as general contractor. Construction of the first power station, the academic Lomonosov, started on April 15, 2007 at the Sebmash submarine building plant in Severodvinsk. However, in August 2008, construction works were transferred to the Baltic shipyard in St. Petersburg, which is also responsible for the construction of future vessels. Academic Lomonosov was launched on July 1, 2010, at a cost of 6 billion rubles, $232 million. In 2015, construction of a second vessel starting in 2019 was announced by Russia's state nuclear corporation Rosatom. The floating nuclear power station is a non-self-propelled vessel. It has length of 144.4 meters, 474 feet, width of 30 meters, 98 feet, height of 10 meters, 33 feet, and draft of 5.6 meters, 18 feet. The vessel has a displacement of 21,500 tons and a crew of 69 people. Each vessel of this type has 2 modified KLT-40 naval propulsion reactors, together providing up to 70 megawatts of electricity or 300 megawatts of heat, or cogeneration of electricity and heat for district heating, enough for a city with a population of 200,000 people. It could also be modified as a desalination plant producing 240,000 cubic meters of fresh water a day. Smaller modification of the plant will be fitted with 2 ABV-6M reactors with the electrical power around 18 megawatts of electricity. The much larger VBER-300 917 megawatts thermal or 325 MW and the slightly larger RITM 255 MW reactors have both been considered as a potential energy source for these floating nuclear power stations. The hull and sections of vessels are to be built by the Baltic shipyard in St. Petersburg. Reactors are designed by OKBM Afrikantov and assembled by Nizhny Novgorod Research and Development Institute Atomenergoprodukt, both part of Atomenergoprom. The reactor vessels are produced by Azorsky Zavody. Kaluga turbine plant supplies the turbo generators. The floating power stations need to be refueled every 3 years while saving up to 200,000 metric tons of coal and 100,000 tons of fuel oil a year. The reactors are supposed to have a lifespan of 40 years. Every 12 years, the whole plant will be towed home and overhauled at the wharf where it was constructed. The manufacturer will arrange for the disposal of the nuclear waste and maintenance is provided by the infrastructure of the Russian nuclear industry. Thus, virtually no radiation traces are expected at the place where the power station produced its energy. Environmental groups are concerned that floating plants will be more vulnerable to accidents and terrorism than land-based stations. They point to a history of naval and nuclear accidents in Russia and the former Soviet Union, including the Chernobyl disaster of 1986. Russia does have 50 years of experience operating a fleet of nuclear-powered icebreakers that are also used for scientific and Arctic tourism expeditions. The Russians have commented that a nuclear reactor that sinks, such as the similar reactor on the submarine in the Kursk submarine disaster, can be raised and probably put back into operation. Floating nuclear power stations are planned to be used mainly in the Russian Arctic. 5 of these will be used by Gazprom for offshore oil and gas field development and for operations on the Kola and Yamal peninsulas. Other locations include Dudinka on the Taimyr Peninsula, Vilyuchinsk on the Kamchatka Peninsula and Pivek on the Chukchi Peninsula. In 2007, Rosatom signed an agreement with the Sakha Republic to build a floating plant for its northern parts, using smaller ABV reactors. According to Rosatom, 15 countries, including China, Indonesia, Malaysia, Algeria, Namibia, Cape Verde, and Argentina, have shown interest in hiring such a device. It has been estimated that 75% of the world's population live within 100 miles of a port city. Atlantic Nuclear Power Plant. Nuclear marine propulsion. Offshore power systems. Soviet naval reactors.